Hi, everybody. So that was super inspiring. I'm going to kind of take us out a little bit into the future. So I am Andrea Lips. I am an assistant curator at Hewitt Smithsonian Design Museum here in New York. And I specialize in contemporary design. And what I want to do with you today is to share a little bit of some early research I've been doing into the contemporary relationship of design and food. Now, of course, the intersection of design and food is much bigger than simply designing the mouthfeel or the shape or even the composition of the food that we see on our plates. What I've been finding is that designers today are equipped with new technologies, and they're collaborating with practitioners in other fields, and they're motivated to solve problems surrounding food. So they're helping to shape the future food scenarios for our kitchens and our ways of eating. So what I'm going to do today then is just focus my talk on food futures, examining the work of designers and firms that seeks to address, in one way or another, issues of food security for the future. Because, of course, as our world urbanizes and our populations swell and the environment degrades, a central question governing the future of food for all of us is, how in the world are we going to ensure that we actually have enough food to eat in the future? So this, of course, leads to questions about food systems and methods of food production, about new food sources and their appearance, about adapting to new food challenges to our food system, and possibly even exploring new food frontiers. And by emphasizing food futures, I aim to demonstrate the different visions that are represented through varying design practices. So moving from perhaps the more predictive into the more speculative, and touching on probable to more, let's say, possible food scenarios in the future. So to organize this research, I've identified 4 themes for my presentation today, the first of which is optimization. So, of course, we need to optimize agriculture to address food security as the world's population swells. So, lots of statistics here, but the UN, of course, projects that global population will swell from the 7.2 billion today to 9.6 billion people by 2050, 70% of whom will be living in cities. So what that means is that we actually need to increase food production by 70% by the year 2050 in order to sustain this population growth. So that's really pretty huge. And to meet these challenges, designers and firms are developing methods to optimize agriculture in urban areas, aided by advancements in agricultural technology. And some of the solutions, of course, may look a little bit strange. There's, no soil in hydroponics or pink light. So Philips Design is a Dutch electronics and lighting company, and they're creating LEDs in the unique spectrum of blue and red light that's optimal for photosynthesis and leafy greens. Now, the cool thing about this is that because the LEDs are a lower temperature, the plants can sit directly beneath the lights, and they don't spend their energy growing upward, they actually grow outward in dense leaves, which optimizes nutrient density and means less growing time. And the illumination can actually be spread then uniformly, enabling farms to plant more per acre. But of course, we're not talking about just traditional outdoor farms. We're talking about more of the vertical indoor farms that we're beginning to see. So this is a farm called Green Sense Farms, which actually partnered with Philips Design. And it's located outside of Chicago and is currently one of the largest indoor vertical hydroponics farms in the United States. So here you see plants that are stacked up to 25 feet high. They're fed this constant stream of nutrient-rich water. They're monitored by computers, and they're harvested as much as twice a week. So what's unique of course, about this is that the plants aren't subject to rain or drought, and crops can be grown year-round. So this is controlled environment agriculture, and it's aimed at meeting the food needs of growing cities and populations. And of course, it's advantageous for cities as well, because it can also make use of existing architecture, which means that the food transportation miles to consumers are reduced. So growing underground, for instance, is a carbon-neutral farm that's located below central London in a World War II air raid shelter. It also uses hydroponic systems and LED technology to grow crops year-round. It eliminates the need for pesticides, and it dramatically reduces the food transportation miles to consumers. So in this instance, produce can be picked, packed, and delivered to London markets in as few as 4 hours. So while controlled environment agriculture looks odd, again, no soil, pink light, causing us to question how this is maybe organic and natural, all the things that we're concerned about today, the solutions actually optimally care for the needs of a plant, focusing on the photosynthetically active part of light and the need for no pesticides. So the plants are actually super happy. It's just a new way of interacting with them. And while optimizing growing conditions and crop yields is one critical approach to food in the future, so too is optimizing collaborative tools and platforms to enable all of us to participate in food production if we want. So Caleb Harper is a leader in this field. He started the Open Agriculture Initiative at MIT Media Lab to develop open source controlled environment agriculture. And he's now collaborating with Target and with the design firm IDEO on the Food and Future Collab. So what Harper does is he builds these collaborative tools and platforms that adapt agriculture and make the science behind it more accessible to break down the point of entry to food production. So it's this idea of accessibility then, which is another theme I wanted to touch on. So designers today are working towards a new networked age of agricultural production, made possible by the same advancements, of course, in agricultural technology that enable vertical farming to succeed. So for instance, for MIT's Open Agriculture Initiative that Harper had founded, it starts with just even small food computers, like this personal food computer, which is a very small unit. It's ideal for makers or schools, anyone interested in learning and teaching about food production through experimentation. And it expands to larger food computers, like this food server, which is about the size of a shipping container and is designed to allow small-scale producers, such as restaurants and cafeterias, to grow food on site. So what happens within these spaces then, inside these food computers, you have climate variables like carbon dioxide, air temperature, humidity, dissolved oxygen, and more that are controlled and monitored. Usage specifications, like operational energy, water use, of course, and mineral consumption, can also be monitored and adjusted throughout the growth period to optimize plant growth. And these sets of conditions then become known as what's called a climate recipe. And so the idea then is that each recipe can produce unique physical qualities in the plants that can vary the size, the color, the nutrient density, the flavor of them. So basically that means that desired plant-based expressions can be programmed into the food computers. And natural climates can even be monitored and programmed to replicate growth conditions. And then these climate recipes could be shared and networked throughout the world for growers anywhere to optimally produce food dependent upon their needs and preferences. So if you love those strawberries from Mexico, well, you could program the climate recipe into a food computer to grow your own. So open source agriculture offers both optimization and accessibility for food futures, but of course this is still in the realm of the production of produce. But how are we innovating to meet the need of protein consumption? How do we make protein more accessible? Entomophagy, of course, or eating insects, is one strategy that is certainly growing in viability. Designers are developing strategies to harvest, produce, and introduce alternative protein sources into our diets. So this is the Lepsis grasshopper breeder by a designer named Mansur Orasana. He's an American who was born in Togo who grew up eating insects. And the idea with this, he created it with KitchenAid, is that grasshoppers are bred, fed, and grow on this hexagonal grid. And then they're harvested into the top of the unit before being placed in the freezer. So theoretically, you could breed up to 100 grasshoppers on your kitchen counter in about a month. So whether or not we can imagine necessarily using something like this, entomophagy certainly advances a known and existing protein source. But what about protein sources that are cultured? Is our food future cultured? So Counterculture Labs in Oakland, California, is seeking to create what it calls real vegan cheese. So this is something that tastes like and mimics animal cheese, but without coming from the animal. So the group fabricates protein structures that exist in real cheese, inserts those into a baker's yeast, which is then put into a fermenter and soaked in a nutrient broth and sugar. It's actually not so dissimilar to the technology used to make beer. You feed carbohydrates to yeast, and it excretes alcohol. Only in these modified yeasts, they don't excrete alcohol, they excrete milk, which can then be turned into cheese. So such biohacking is part of a bigger movement among scientists and designers to apply synthetic biology to food production, and of course only begins with cheese. Cultured meat is joining the conversation as an option to create more sustainable protein sources. So similar to cultured cheese, cells are placed in a nutrient mixture that helps them proliferate, and then they're attached to a biodegradable scaffold, much like vines wrap around a trellis. There, the tissues can be stretched and molded into food, which could be cooked and consumed like processed meat. So theoretically, this process would be efficient enough to supply the global demand for meat. But what would disembodied meats or prepared insects even look like? So that gets into issues of aesthetics in the future of food. So as technology and science and expanded food sources are explored as options for a sustained global food supply, how might food's aesthetics be impacted to ensure that this stuff is even remotely appetizing to us? So designers are proposing new possibilities for food's appearance, moving into the more speculative range of design practice. So insects, of course, are certainly taking the form of insect flowers and protein bars, but why not abstracted bento box-like bites? So here we've got UK-based designers who are developing Ento as this roadmap to introduce entomophagy to northern diets. So they've got ground insects, spreads, and croquettes that then make way to more sushi-like meal packs, and eventually the dried, unprocessed insects themselves. Or you've got complete abstraction, which is the intention behind Insect au Gratin, a speculative project by Susanna Suarez, who's a London-based designer. So what she's done is mixed insect flour with other ingredients and extruded it through a 3D printer to create new food forms, which are actually based on the microscopic views of insect eggs. So the shapes are totally weird and seem foreign, but the designer proposes that they be thought of as a 21st century fish stick. So why not? It's just enabled by 3D food printing and insect meat. And new food aesthetics could also take the shape of a familiar food like a meatball. So Space 10, which is a design studio based in Copenhagen, started with the meatball because they recognize it as quite a ubiquitous food across the globe. And they use that then as a canvas to visually explore future food scenarios of alternative ingredients and technological innovations. So on the upper left, you've got this 3D printed meatball that kind of looks like a wiffle ball, and it converts insect meats, algae, and beet leaves into a meal. There's also the crispy bug ball in the bottom right. The artificial meatball presents just that. It's cultured meat grown in a lab, prepared and cooked like a meatball. But other designers are continuing to push our thinking of aesthetics for alternative food sources. This is a project called Dressing the Meat of Tomorrow by a London-based designer, James King. And so in considering the aesthetics of cultured meat, he questioned what the shape and size would look like if meat no longer was limited to anatomical constraints. So how might we choose to give shape and texture to cultured meat in order to better remind us where it comes from? So the designer envisioned a future where there are these mobile animal MRI units that are kind of scouring the countryside looking for the most beautiful examples of livestock. And an animal then could be scanned theoretically from head to toe, creating these accurate cross-sections of their anatomy. And the most aesthetically pleasing could be used as scaffolds to create these molds for in vitro meat, which is what you see here. So the aesthetics of what I like to consider disembodied cuisine are more like science fiction, but they do speak to future scenarios that could impact the way that we eat. And how are we adapting to other scenarios that could impact food futures? This leads into the last theme that I'm going to touch on, and that's adaptation. So the methods and tools of design enable it to synthesize and translate advancements in science and technology. So when considering possible food futures, designers are proposing ways to address possible food endangerment and extinctions, and are pushing into new food frontiers. So for instance, how do we adapt to species endangerment that could impact our future food security? So this is a project by American designer Laura Alcorn. It's called the Human Pollination Project. And it proposes a set of tools that would allow humans to replace the pollination services of bees. Because of course, honeybees pollinate around 90 crops or so, almost a third of the human food supply, but their populations have been collapsing. And so by designing this toolkit, this hand pollination toolkit, the designer is really seeking to spark a dialogue around the social and environmental implications of the disappearance of these primary pollinators. Whereas other designers are proposing more direct solutions to the problem of species endangerment. So this is a project by Dutch designer Laura van Os called Victoria, and it's the world's first organic pesticide to fight against the varroa mite, which is the parasite that's largely responsible for bee mortality. So traditionally, oxalic acid is used to fight varroa mites, but it's very harmful to bees and to their environment. And so Van Os discovered that Victoria rhubarb naturally contains high quantities of the acid, but without the bad side effects. And so she studied the best way to extract and to thicken the acid, and now sells these elegant little ampules of the Victoria powder to beekeepers who add distilled water and directly apply the paste to a beehive. And designed objects can also make us consider how we interact with and value our resources. So this is a seed safe by Spanish designer Martí Guixé. And it encourages the personal collection of seeds from your vegetables and fruit as you eat them, storing them as if they were small and precious pieces to later be planted rather than thrown away or composted. So it's this small, somewhat unassuming object. It's intended to sit on your countertop, but it does suggest that seeds are as valuable as money and encourages direct action at the scale of the user to consider the preciousness of food. Whereas the Svalbard Global Seed Vault, which is built into the mountainside on a remote island near the North Pole, is a seed repository used by almost all of the world's governments to ensure that global crop diversity is maintained. So the permafrost in the glacial environment actually ensures natural cold storage for seeds. So think of this global seed vault as almost this hugely scaled up seed safe with currently almost 1 million seed samples that covers half the world's known crop diversity. So the facility itself is designed to last 1,000 years, to withstand global disasters, nuclear war, even an asteroid strike. And it's kind of an insurance policy, with seeds from all known varieties of food crops kept for safety that would then be the source material to breed new plants in the face of a disaster. So, I mean, here we are literally at the edges of our own planet, adapting to Earth's possible future food scenarios and challenges. But designers are actually looking even further than this. They're exploring new food frontiers in space. So not unlike NASA's experiments to grow food in microgravity environments using synthetic biology, here we've got a piece by British designer Daisy Ginsburg that imagines fruit grown in a dark tank in space that is made from redesigned yeast that feeds on electricity rather than sunlight. So it's electrosynthesis rather than photosynthesis. It's, again, a cultured means of producing fruit, not unlike the cultured cheese or the meat that we pointed to earlier, but it's designed to sustain life without the benefit of the sun. So, as you can see, designing the future of food takes many twists and turns in our attempts to ensure food security. And the approaches are wide and varied. They're conventional and provocative. And they make us pause in thinking about what exactly we want our food future to look like. Thank you.